So, first thing, look at these lines, right? Look in the solubility curve, all these lines in here, right? Y'all see all these lines going everywhere? All right, what these are solubility curves. They're saturation lines. And if we look at their direction, we can tell if down here, right, if our temperature, right, if changing the temperature will either increase the solubility, decrease the solubility, or don't really affect it, it kind of stays the same, right? So increase, decrease, stay the same. So if we look at first, which ones does the temperature make it go up? Increase solubility. So look how this line is going up, and this one is going up. So all these lines that are increasing, moving up from left to right. Okay, so as our temperature down here gets hotter, right? As our temperature gets hotter, the ones where the lines are moving up in this direction, those are the ones whose solute, you can put more solute in them the hotter they get. So they increase the solubility, how much they can dissolve as the temperature increases. So let's step back. Let me get rid of some of these arrows. Now, look at this one. Look at NaCl. Right? So if we compare right here, where it ends up at about 40, right? Over here, where it starts at about 34. So if I increase the temperature by 100 degrees, it only gains 6 grams of solubility. So yes, its solubility does increase as you increase the temperature, but not really. Like, not enough to really brag about, just, I mean, it increases a little bit, but not much, right? So, we're going to say that one's not really affected. It's affected the least, certainly. But now look at this sucker down here, Cesium Sulfate. Do y'all see this? See how it's going down, right? It's going down, right? As this temperature gets bigger, it's going down. So this one's solubility gets less. You can't put as much solute in it. You lose the ability to dissolve solute as you heat it up. This is most commonly in our gases. I don't know what cesium sulfate is. It sounds like a salt though, so it's probably not a gas. But most gases do get worse as temperature increases. All right, up next. I'm gonna grab a different color so we know we're doing something different. All right. Up next, we're looking at how can we tell if it's saturated, unsaturated, or supersaturated. So let's just pick a line. All right, let's pick lead nitrate. This line right here. Okay, we're gonna look at this one. So it's all about where the plots land. So if we're thinking about, say it's like 20 degrees, right, and we're putting in, about 57 grams, right? If we find where that is, right, it hits right here. If our points like this one, or maybe if we're at 50 degrees, right, and this much over here, right there, see how they land on the line? This on the line is saturated. Okay. So when we're plotting our points, when our temperature and our solute, if we plot it and it lands on the line, it's saturated. Now, if we plot these lines, say we didn't have this much, right? Say we only had 45 grams at 20 degrees. So this would end up putting us about right there, right? This is below the line. Or maybe we did not have 80 something grams, right? Maybe we only had like 60, right? When it was 50 degrees. So this would put us right there. It's below that line. If it's below that line, this is unsaturated. And then the final version of that is, what if it's above? So if we would have had more, say we ended up here, we were above the line, or here, above that line, then this would be called super saturated. Look at that beautiful handwriting. Right. So there's that. I'm going to kind of clear this off. I don't know how to do it quickly. Microsoft Paint, you know, probably outdated printer. It'll take forever. So backing up, backing up, backing up, backing up. Sorry for all you folks good at tech to know how to do this faster than me. I'm learning. All right. Uh-oh, went too far back. There it is. So I'll zoom back in a little bit. Now, finally, we got identify a specific amount of solute needed to form a solution. So this is kind of what we just did. We're just, instead of focusing on it being saturated, supersaturated, or unsaturated, what we're going to do, if it's like, you know, if we're looking at 50 degrees and we're talking about this line here, potassium chlorate, and it was like, how much KCl do we need at 50 degrees Celsius to form a saturated solution? You come up at 50, you find that spot on the line, you follow it over, I'd say about right there, 42, 43 grams. That's it. You just find your temperature, you go up, wherever it hits that line at, wherever it hits the line, you go across your y-axis, see what number's there, and that tells you what you got. All right, so if you watch this video, hopefully you now know how to tell what happens if the temperature is changing. Does it increase, decrease, or stay kind of the same? The solubility, how much solute you can put into the solvent. You know how to look at it and see, is it saturated, is it unsaturated, or is it supersaturated? And finally, you just know how to look at it. Just look at it, apply it together. Let me know if you have any more questions. I gotta figure out how to stop this thing. Bear with me. Bear with me. I saw that sucker. Stop recording. I don't know what to do. All right. See y'all later.